One of my absolute favorite topics to talk about is the sun. It's fascinating, it's interesting, and it's very mysterious. It is also the key to life here on planet Earth. So let's talk a little bit about our star. When we talk about types of stars, our star is a middle-aged white star. Now, most of the time when you were a small child and you would color a little picture and you would put the sun up in a corner, you typically picked a yellow crayon to color the sun. We'll explain why it appears yellow and why your mind tells you it's yellow often, but it actually is a white star. We believe it is about 4.6 billion years old since the beginning of our solar system. It is 93 million miles away, and it takes light 8 minutes to get from the sun to the earth. So if a little tiny photon of light leaves the sun before it hits your eyes here on earth, we're talking about a period of about 8 minutes. I've had people ask me questions like, if the sun would disappear, would we know it immediately? Nope, we would know it 8 minutes later, because no information, not even gravity, can get to us from the sun faster than the speed of light. The distance between the Earth and the sun, as you recall, is called an astronomical unit. Some situations you're going to hear our sun referred to as Sol, S-O-L. And they refer to Sol, some people pronounce it sols, and that is the star. That is another way of saying our star. A lot of things having to do with the sun are going to have the prefix helio, and that is because the Greek god of the sun is called, or was called, Helios. And so if you hear Helios, odds are it has something to do with the sun. So how big is it? It's huge. It's absolutely amazing. If you could draw Earths on a picture of the sun, you would have to draw 110 of them to go from one side to the other. I cannot draw small enough to accurately draw 110, and you're not going to want me to spend the time to put 110 Earths would go from one side of the sun to the other. It is almost 500 million miles across. That is unfathomably large. The volume, you could hide 1.3 million Earths within the sun. If you talked about the diameter of Jupiter, and I like this illustration right here. Here's the Earth, and there is Jupiter, and there's the sun. It's very, very, very large, hard for our human brains to comprehend. Our star is made of mostly hydrogen and helium. This is what most of the entire universe is made out of, and it is real close to the composition of the entire universe. The universe is mostly about 75% hydrogen and about 25% helium. So it's not exactly the same as the rest of the universe, but it's definitely mostly hydrogen and a little helium. Every other element you have ever heard of, copper, gold, zinc, uranium, platinum, iridium, whatever, every other element makes up less than 0.2% of the sun. So this is a very small fraction of what is actually making up our star. It's mostly a big ball of hydrogen. The matter that makes up the sun is in a special state of matter called plasma. Plasma, we'll talk about in the next slide a little bit. It does not have a solid surface. It is like a fluid. It's kind of like a slushy, if you want to think of it like that, but it's hot, very hot, not cold. And if you would be so sad to actually land on the sun, there is no solid surface. You would fall and fall and fall and fall and fall and fall and fall until you hit the core. There is not a solid surface in the sun. You would be burned up long before that, but that is what would happen. This is a really lovely picture. This is a picture of the planet Venus in transit, and We get an awful lot of information about how big planets are and things like that by looking at them as they transit in front of the sun, because that's a very nice way for us to do size comparison, etc. So I mentioned plasma. What is plasma? First off, plasma is not blood plasma. It's one of those very unfortunate things with the English language. Blood plasma is your blood minus the red blood cells. And I've had many students through the years that donate plasma. They actually get paid. They make money every week going in and donating their plasma, or selling their plasma. So this is not, it has absolutely nothing to do with your blood. Same word, different meaning. Plasma is the fourth state of matter. If you've ever taken a chemistry class, they always talk about the states of matter, the forms matter can come in. And matter can come as a solid, a liquid, or a gas. Everything is made out of a nucleus with electrons rotating around the outside edges. If you take a material and you get it really, 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 really nutty hot, what happens is these electrons cannot hold on to the nucleus, or the nucleus cannot hold on to the electrons. And the electrons run free. They actually are unbound from the nucleus. And you end up with an actual soup of electrons, protons, and nuclei. So instead of having nice, pretty, structured atoms, what you end up with is negative particles and positive particles, and they're all moving really, really, really crazy fast. Now, plasmas are so full of energy that they give off light. And they're not all very exotic. You have plasmas, there's plasma probably in your room right now. A couple of the common ones are fluorescent lighting. Plain old ordinary fluorescent lightings are tubes. They've got a little mercury gas in there. And the mercury gas molecules are gotten so hot by streams of electrons, electricity, flowing through that mercury gas, they give off light. A candle flame is actually a plasma. It's not a solid, it's not a liquid, and it's not a gas. If you have matter that actually glows, if it glows, it's a plasma. Another common example of plasma is lightning. The air gets heated so hot that it glows, and that's because the lightning strike has actually created a stream of plasma. So our sun is a big wad of this charged particles. Our sun actually rotates. Just as the Earth spins on its axis, the sun also spins on its axis. And remember when I was talking about the ice skater pulling her arms in, that when the ice skater was all spread out, she rotated very, very slowly. And as she pulled her arms in, and her matter got close to the center, she'd spin very, 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 very fast. Well, to give you kind of a reference, the original accretion disk that made our solar system, Pluto, our old friend Pluto out here, has a orbital period of somewhere in the neighborhood of 250 years that it takes for Pluto to go around the center. As you got closer and closer to the center, where our star is, the rate of rotational speed gets faster and faster. Here on Earth, how long does it take for the Earth to go around the sun? About 1 Earth year. As you get closer and closer, it's going to spin faster and faster. The sun itself still has conservation of angular momentum. And what happens is this big rotating ball of plasma spins on its own axis. And because it is not a solid and the particles are not bounded together, what occurs is that different latitudes actually rotate at different speeds. The pole, near the north and south pole of the sun, it takes about 35 days, a little more than an Earth month, for that to rotate. About the equator of the sun rotates in about 25 days. Well, as you can imagine, if this is rotating very, very fast, and this is rotating more slowly, what that means is this whole bit in between is not going to hang together. It's going to actually rip apart. And that ripping apart is what leads to things like solar flares, sunspots, and coronal mass ejections, which we're going to talk about. I'm going to ask you to watch some of this video. It is 3 years of the sun in 3 minutes. You do not have to watch all of it, not unless you find it mesmerizing. As I said, absolutely love the sun. And when we come back, we're going to talk about the layers of the sun.